So you ask, what are we doing today? We're converting and using the different forms of quadratics, and how do we know we understand? We're going to move between those forms and use them to graph. Now these are the three different forms that we're using. We have the vertex form, ax minus p plus q, which allows us to find our vertex in the form pq. Remember, this one is opposite world. And remember that the a value tells us what we multiply steps by. It also tells us if it's opening up or down. When you do that, I want you to think, if it's plus, it opens up. If it's down, if it's negative, it opens down. And we practiced that a few days ago. For the standard form, you'll notice we also have our a value, and guess what? The a value is the same as before. We have a bx, but we also remember from our last day, we remember that the c value represented the y-intercept. Now, you guessed it, for the intercept form, we still have exactly the same as before. It basically represents the steps, the multiplication that we use for our steps from the vertex. Now you'll notice that the intercept form looks like a factored form. So what I'm going to do is I'm going to give you a recipe for this. The key idea is this: when you're actually working with something that needs to be put in intercept form, you must, one, common factor first. And then two, simple factor. The bracket. You'll see an example of that in today's questions. Now, what I want you to remember is, not all the time will we be able to convert between all three forms. Sometimes the forms are just absolutely ridiculous. So anytime you have to use, say, a quadratic formula to find the x-intercepts, which is what the intercept form finds, you probably have something that doesn't factor well, which won't be able to be put in intercept form like this very easily. Now, let's go and discuss how all of these stages, all of these different forms can be found. We'll discuss how it's done, and we'll use this chart that we have on our sheet to kind of identify what we're going to do. Now I want you to write really small here. To move from standard to vertex form, which is this one here, you have to complete the square. For going from completing a square all the way over to standard form, we have to do the following. I'm going to draw a nice long arrow, and we're going to put a bunch of steps. 1. You're going to rewrite our equation to be this: y is equal to a x minus p plus q. 2. You're going to just expand the x minus p. x minus p, x minus p, and leave it inside a bracket. Then for 3, what you're going to do is you're going to multiply the 2 into our bracket. And then 4, you're going to add the q value. You'll see how we do that today. Now, going from standard form to intercept form, this is the recipe for that. The recipe is just this. 1, you common factor first. The a value. 2, after you've done that, then you simple factor the bracket. To go back the other way, you just you reverse everything. So in this case, you're going to start with 1. You're going to expand x minus r, x minus s, and then you multiply by a. And you get the original standard form. Now, the final stage here. If we wanted to move from intercept form to vertex form, what you have to do is 3 things. 1, so 1, what you're going to do is you're going to find the average or the axis of symmetry. And 2, you're going to sub the AOS into our equation to find y. Now that you've found y, you take that x and y, and that is our vertex. So 3, the AOS and y is our vertex. And the a value from our original equation here is just the a value that we use in this equation. And you already know how to take a point and convert it into vertex form.